All right, so let me go over a couple of things as kind of a review of how to do simple interest. Let me go over the formulas that you need to know for this section when you're working on this worksheet, and then we'll talk about the other worksheet as well. So, simple interest, there are two formulas. They kind of work together. One of them is going to be the future value equation, which you're going to need for the second part of this. I'll just put both of them up here at the top. Future value, we'll shorten as FV, is going to be P plus I. So let's label these. This is future value. P stands for either principal or present value. At the start of the loan, and then I is going to be interest. So future value is just simply whatever the present value is plus whatever interest that loan gains over whatever amount of time the future value you're trying to calculate is. So that is our formula for future value. And then our formula for interest, the I in that first formula. So this I interest is the same as this I. And how we calculate this is P times R times T. And this again is interest, if we're trying to calculate the interest on a loan. This is the principal amount or present value. R is going to be our rate. In decimal form. Sometimes the rate is given as a percent in a lot of problems. As you can see here, you're given percentages. You have to convert those to decimal values before you put them into your formula. And then finally, the T is going to be time. And the units for our time is going to be in years. The fact that the time is in years is important, and that the rate is in decimals is important, because a lot of times you're not going to be given the value of time in years. It's going to be given to you in either days or months or weeks, whatever it is, and you have to convert to years before you plug it into your formula. Someone asked if there's a place to submit the class handouts. Not for today's, and it hasn't been for before either, right? Yeah, a lot of the in-class handouts are just things that we're working on in class, and materials for you to look back at and study when it comes to exams. Also, most of the time we're not going to be turning in this classwork that we do, which is why you need to make sure that you have the correct or you understand how to do it by the end of class. Because you're not turning these in, you're not getting feedback on them. So the best way to complete these is to do the problems and then check them with either the apprentices or myself to make sure you're getting them correctly. Or if you're not getting them correctly, make sure you understand what you did wrong and how you can avoid those mistakes when the exam comes. Right. So there's a few problems on this page that deal with either asking you about interest, which I think the first question, number one, is asking you to compute interest for these two scenarios. And then the second problem is asking you to compute future value for these two situations. So you're going to use these two formulas for those. The only thing I want to talk about here specifically on the worksheet is if you look at parts A and B for number 1, they're pretty much identical. The only difference that we see here is the borrowed amount is the same. The percent rate, interest rate is the same. The only difference here is the time that the money was borrowed for. First one says from July 1st to December 31st. Second one says July 1st through December 31st. That's going to be the distinction here. This to December 31st does not include December 31st. And through includes December 31st. All right, so that's the distinction there between the two. So I know it's a very minuscule difference there, but not including December 31st versus including December 31st is going to make a slight difference in the interest calculation because the time is different for the two. Even though it's just 1 day different, this one is going to have one less day than this one, right? So December 31st being not included would be a certain number of days. You need to figure out how many days that is from July 1st to December 31st. Not including December 31st, and you're going to do the same thing, but you're going to include December 31st. So when you get to the formula part, the time, this one should be one less day than this one. Now, granted, you still have to put that into years as your units, but there's going to be a slight difference because this doesn't include December 31st and this one does include December 31st. So you guys will work through that example using the formula, this interest formula for the first problem, and then our future value for the second problem. Now the future value formula you see has an I in it, which means you're going to need to use this formula to figure out what the interest is before you plug it into the future value formula, because the question down here only tells you the present value and the percent and the years. So those 3 pieces of information are what you need to calculate the interest I, and then you'll be using that interest in your future value formula to figure out what the future value of the loan or the value of the present value, future value is going to be for this situation. And then on this one, I don't need to make any notes. I guess my note would be find I first. So find interest first. Then find future value for these two for this number 2. All right, so use I equals P times R times T to find interest first, and then you can find future value using the future value formula. Any questions on the formulas or anything I said so far?
Yeah, for 1A and B, will we have to convert the days to a year?
You will. So it's less than a year, right? So it's going to be some fraction of a year, and you need to figure out what fraction that is. So, for example, in the second one here, if I had 245 days, let's say we're working with this example, if I want to convert 245 days to years, and I want to convert to years, how would I do that? Well, we multiply by a fraction to convert from days to years, and we use the ratio of how many days are in a year as a conversion factor. So we know that there's 365 days in 1 year to do that conversion, right? So if I do it this way, my units, my days will cancel out here, and I will be left with the units of years. And all we're doing here is we're multiplying 245 over 1 by 1 over 365. So we multiply straight across and we get 245 out of 365. And you can probably reduce that fraction into simplest terms before putting it into the formula, right? So 245 days is the same as 245 out of 365 years. Right? This is the fraction of a year that this number of days represents. So you would do something similar to that here once you figure out how many days this is. You'd be converting that to years. Does that answer your question? We're good?
Yes, thank you.
Any other questions? The years doesn't have to be a fraction. Are you asking that to make it a yeah, you can make it a decimal. Although you don't really want to lose. You don't want to lose accuracy. So if you're rounding to decimals, I would keep like 4 or 5 decimal places until you get to the final answer. Because if you round like the number of days to 2 decimal places, and then you plug that into your formula, and then you round that again to 2 decimal places, you might be like 1 or 2 cents off in your answer, and we don't want to be off at all in when it comes to like our final answer, because these are essentially questions that you're going to see on you guys use WebAssign. On WebAssign you'll see questions like this, so you don't really want to round too early. The year, I mean, it is a decimal. You can use it as a fraction, or you can just use a calculator to change this to a decimal and work with that decimal number as well. I had a question about how do we count the days for problem 1. You're gonna need to kind of count month by month and figure out how many days are in each month, and then add those together. So like July has 31 days, so if you have all of July counted, that's 31, right? And then you'd have August, which is another 31 days. So that like month by month, you might need to look at a calendar to figure out how many days are in each month. But you're going to want to add those up. You don't really have another choice there. Let's actually do this. I would round the... So if we were doing this, if we were simplifying... let me see what it simplifies to, first of all, as a fraction. This reduces to 49 over 73 years. So that's the reduced form of this thing. So we could say t is equal to 49 over 73 and just plug that into our formula, or we can just do 49 divided by 73 on a calculator, and I would say keep like 4 or 5 decimal places, so that would be 0.67123. I would keep 5 decimal places just to be safe there. Years. So you can use either one of these two in your formula. Great question. So someone asked if remember how on the first example I said this one does not include December 31st. So you still count all of the other days from December 1st to the 30th, which means if December has 31 days, then when you're adding December to this day count, you only want to add 30. So you just take away that one day at the end, because we don't want to include that last day. Right? So you would add 30 for the month of December, whereas on this one you're going to include all 31 days of December. So you would add 31 at the end for December for the second part. I do want to go over a little bit more of day calculations, like how many days are from this day to this day, but that's going to have to do with the other handout we're working on, so hopefully that'll help with this one as well. Are there any other questions that I didn't answer maybe? I think I looked through everything and I answered everything for this handout at least. Are there any other issues we have? How do you calculate the percentage with the fraction? Do you mean how do you convert this to decimal? Is that what you're asking? Right. So 2 3/4, you either know that 3/4 is 75% or 0.75, or use a calculator for it. Either way, 2 3/4 is 2.75% as a number, and then to change that to decimal, we move the decimal 2 places this way, meaning the decimal is here. So our rate here would be 0.0275 as a decimal number, right? So 2 3/4% is going to turn into 0.0275. So converting from decimal to percent to decimal, we move the decimal 2 places to the left. To change fractions to decimals, you just divide them using a calculator. Same thing for the other one. 3/4 is just 0.75. So this will be 11.75, and then you would move the decimal 2 places over to the left to change it to decimal rather than percent. Any other questions on this page? And again, once you start working on it, if you have questions, either one of the TAs will be in your breakout room, or I will be in the room. We're missing one of the TAs today, so we'll still have 3 rooms, but I'll take one of the rooms, and then I'll kind of shuffle back and forth between all 3 rooms as well. But yeah, so I do want to talk about the other worksheet as well, because it goes more into average daily balance, which was also part of the module. So let me actually work through this first example before I let you guys loose into your breakout rooms. So in a question like this, where Mr. Spendit's credit card shows that for... Wait, why is this different than what I have? Is this what you guys have? This is what you have on Canvas, right? Okay, it is. Okay, scared me for a second. Let me check. Okay, Mr. Spendit's credit card shows that for the billing period of June 24th through July 28th. So that's our whole billing cycle, which is kind of like a 1 month-ish billing cycle, as most credit cards work with. He made a payment of $100 on June 29th. So we'll highlight that as one of the transactions. Payment of $100 on June 29th. Bought gas on July 1st. I'm actually going to color that in a different color, because making a payment versus buying something with your credit card are 2 separate things. And then had dinner on July 3rd at a cost of $55. So I'm highlighting these differently because the payment is a negative value, whereas buying gas is a positive value. When we talk about balance is a value that the user owes on their credit card. So if you get a credit card, you go to the store, you buy something, your balance goes up, right? When you buy something. So when he buys gas or when he pays for dinner, those are things that are going to increase the balance. When you make a payment on a credit card, that's you paying from your bank account into towards your balance. So this $100 payment is going to reduce the balance of the credit card, right? So now that we have that, we have a previous balance of 506. We'll use that to figure out what the balance is throughout the month. and we're asked to find the average daily balance. To find average daily balance, this is the process. So first we're going to break apart our month, which is June 24th to July 28th, based on the purchases and the payments that were made during that month. So we're going to have time intervals. And the time intervals are going to be from the start of the cycle, which is June 24, to the first transaction. So the first transaction after June 24th is this June 29th, which was the payment, right? So we're going to go up until including the day before June 29th. So we're going to go from June 24th to June 28th. Because on June 29th, we're going to have a different balance. So June 29th starts the next time interval. So each of these transactions, the June 29th, the July 1st, the July 3rd, those are all going to start new time intervals. So June 29th is going to start a time interval. July 1st is going to start a new time interval. And July 3rd is going to be the start of a new time interval. So each transaction you do with the credit card is going to start a new time interval for us. Now, if we're going from if this time interval is going all the way to the day before July 1st, what is the day before July 1st? Or what do I put here as the last day for this time interval then? What's the day before July 1st?
June 30th.
June 30th, perfect. So that's just going to be June 29th to June 30. And then if this last interval is going to start on July 3rd, that means this is going to end on July 2nd. And then where does my last interval end? It goes from July 3rd to what date?
28th.
28th. Why 28th? Where are you getting that?
From June 24th through July 28th.
Good. The billing period from the beginning of the question, this is our starting. That was at the beginning. And then we should always start and end with our billing cycle. So we start on June 24th because that's when the billing cycle starts. And it says, notice how it says through July 28th. So we want to include July 28th here. So we go all the way through July 28th here. Next, we're going to figure out how many days each one of these is. And I just realized we're going to need room underneath these, so I'm going to shift everything up. I know you might not be able to do this, but we're going to need to do some calculations after we do this, so I need room below this. So, number of days. We need to figure out how many days each one of these kind of windows is, right? And each one of these is through. So, June 24 through June 28. How many days is that if we're including both June 24, if we're including the first day and the last day of that time interval, how many days is that?
4.
I'm seeing 4 and 5 in the comments, which if you count on your fingers from 24 to 28, including the 24 and the 28, that's actually 5 days. So when you do 28 minus 24 and get 4, what actually happens is you're not counting this last day when you do that. Okay, you go 24, 25, 26, 27. Those are the days that you count when you do 28 minus 24. So what you want to do, if you still want to do the subtraction, because that's easier to do, all you have to do is just add 1 at the end. And that's how we're getting the 5 here. Okay, so if you want to, you can still subtract days. You can still subtract the numbers, like 28 minus 3 on this last one. You just have to make sure you add that extra 1 for the last day that you are not counting. June 29, June 30, that's obviously 2 days. We can count that on our fingers. July 1st, July 2nd, that's obviously, again, 2 days, because we can count that on our fingers, right? That's 2 days. And then the last one, 28, or July 3rd to the 28th. You really don't want to count that on your fingers. That's a lot of counting to do. Instead, what we could do is 28 minus 3. But again, when we do 28 minus 3, we're not counting that last day of July 28th. So we need to add 1 to that to get our final total, which will be 26 days. Okay, so that last window is going to be 26 days, the last interval. All right, so now that we have our intervals computed with how many days it is, we are also going to write the balance for those time periods, for those time intervals. When the month starts on June 24th, all the way until he makes this payment of $100, he has a balance of $506 because that was the previous balance from the month before. So from the previous billing cycle. So he has a balance of 506 to begin. And then on June 29th, he makes a payment of $100. Is the payment going to increase or decrease this balance?
Decrease it?
Decrease it. Perfect. Because when you make a payment, you're reducing your balance. You're reducing the amount you owe, right? So in the second window here, we'll say 506 minus 100 equals 406, just to show that we did apply that payment to the balance, and now there's only $406 owed for these couple of days, right? So for the first 5 days of the month, there was $506 that he owed. After that, he made a payment. So the next couple of days, he only owes $406. And then on July 1st, what did he do? He bought gas for $42. And that's going to increase the balance. So we take the balance that we had, we add 42 because he bought gas for $42, and it's going to be $448 for those 2 days after that, or the day he bought gas, and the next day, the balance is going to be $448. And then while it's $448, on July 3rd, he paid for dinner, which was $55. So that's going to increase the amount of money that he owes again. So we're going to add 55 more to this, which is going to raise our balance to $503. And he's going to end the month, or end the billing cycle, billing period, on a balance of 503. Now, what credit card companies do is they don't just look at how much money you owe them at the end of the month and calculate the interest that they're going to charge based on that amount. What they do is they look at how much you owed them for how many days and calculate it based on that. It wouldn't be fair it wouldn't be balanced or fair if I, for example, had a credit card and I bought, let's say I bought like a laptop for $1,000 at the beginning of a month, and then I owed them $1,000 for a whole month. If they charged me the same interest as if you had bought a laptop on like the last day of the month and charged $1,000, because you only borrowed that money for 1 day, right? So it wouldn't be fair for them to charge the same amount of interest to me and you, whereas I borrowed the money for a month, you borrowed the money for 1 day. So what they do is they work on a day-by-day basis. So they look at this and they say, okay, for the first 5 days of this billing cycle, you owed the credit card company, or Mr. Spend It did, $506. And then for the next couple of days, he owed them $406. And then for the next couple of days, he owed them $448. And then for 26 days of the month, he owed them $503. So we're going to include those, the calculation is going to include those days and those balances when calculating the average daily balance. So how do we find this average daily balance? Well, we take, let's start working on it. So average daily balance, I'm going to shorten as ADB. Our calculation for this is going to be as follows. We're going to take each time interval, the number of days it is, we're going to multiply by how much the balance was for each time interval. So we're going to do 5 times 506 plus 2 times 406 plus 2 times 448 plus, and then the last 26 days there was a balance of 503. We're going to essentially, this product, what this is doing is it's saying on the first day you owe 506, on the second day you owe 506, third day, fourth day, fifth day you owe 506. We're adding those together, right? We're getting like a total amount owed for the whole month, and then we're going to divide that by the number of days in our billing cycle. So we're going to divide this whole thing We're going to divide that whole thing by the total number of days in this billing cycle, which will be the sum of these days. Right, so we're going to have 5 plus 2 plus 2 plus 26 as our denominator here. And we're going to compute all of this. Right, you will need a calculator to do this. In the situation of an exam, either in the situation of an exam, I think I would want to see this answer, and then the rest of it would just be plugging into a calculator. So as long as you know how to do the time intervals, you know how to count the number of days, you know how to calculate the balance for each interval, and then you know the formula for calculating average daily balance, or the process for calculating average daily balance, you could stop here and say that whatever this answer is would be the average daily balance. But if we were to do this on a calculator, we end up getting 17,316 divided by 35 days we're in this billing cycle. 17,316, which comes out to be in dollars 494.74. Right, so the average daily balance, meaning on average, Mr. Spendit owed this much per day. Right? He never exactly owed this much because he owed a 506 and then 406 and then 448 and then 503. Those are the numbers that he owed. But on average, per day, he owed this much. Right? On any average day, this was the amount that he owed the credit card company. And then over here, I'm going to show you how to do the finance charge calculation. Find the finance charge with a rate of 21%. So the finance charge is essentially going to be the formula that we saw for interest on the previous page. Interest was equal to P times R times T. In this case, our P is going to be our average daily balance, so 494.74. The rate that's given to us in the question is 21%, which we can convert to 0.21 as a decimal. And then the time we're going to use is, we know how many days it is, right? We added these together. We saw that it was 35 days. So the time is going to be 35 out of 365 because we need it in years. All right, so those are the three things we'll plug into our interest formula. which means interest equals 494.74 times 0.21 times 35 over 365. Which again, you can leave like that on an exam, but if we have a calculator, which we do for homework and classwork, we get that the interest charge is $9.96. So the two answers here are our average daily balance was the 494.74, and then our interest, or the finance charge, the interest for this billing period will be $9.96. Any questions on the process or anywhere in the problem?
I have a question.
Mm-hmm.
So Mr. Spendit is gonna owe an interest for the whole period, the $9.96. It's not per day.
No, it's for the whole period. So what we do in general is, this was his ending balance, the $503 is what he owed at the end of the month. This $9.96 would be added to that to figure out the starting balance for the next month.
Gotcha. And then another question: in real life, does interest accrue as soon as you spend, or does that depend per company?
Interest in the real world works like this. They will only charge this finance charge, this $9.96, if you have some kind of balance at the end of the month. If you didn't pay off everything at the end of the month, they would add that which he didn't, right? So he started with 506. He ended with 403 while only paying $100 in the middle there. That may have been the minimum payment or whatever, or maybe a little bit more than minimum payment. But because he didn't pay off his whole account, because it wasn't zero, he's going to get charged this $9.96 at the end of the month, and you'll see that on your credit card statements as like a finance charge. If you ever keep a balance on your credit card statements, you'll see that as a finance charge just get added to your current balance.
Oh, okay. Thanks.
Yeah, so it's not as soon as you buy something they add the interest to it. It's if you buy it and then you don't pay it off at the end of the month, that item that you bought, however many days you basically borrowed that money for, is what they charge interest on. Cool. Good questions. Any other questions about the calculations or credit cards in general?